my name is Preetham, and I'm going to briefly discuss about acids and bases. Acids and bases. As we usually know that this topic is we are studying from 6th standard onwards, and this is a very familiar topic to all of us. So let's start. First of all, we are going to have a look at what we are going to see in this whole presentation. So, first of all, So we are starting with what are acids, examples of acids, bases, examples of bases, then differences between acids and bases, and types of acids and bases. Then again will see applications of acids and bases. Applications means usually it is uses in our daily basis of life. So let's start. Our first slide is of acids. Acids are substances that produces hydrogen ions, means H plus ions when mixed in water. So let's come to properties of acids. So properties of acids, first one is they are sour in taste. Then their pH value uh, lies between 1 to 7, means always less than 7. An acid therefore can conduct electricity. They are good conductors of electricity. They are also corrosive in nature. Okay, so let's come to examples. Examples, hey, as you can see that names of acids, chemical formulas, and where we can find those acids, all are given in sequence. So let's start with that. First is hydrochloric acid. Hydrochloric acid is formula is HCl, and they are basically seen in gastric juices in our body or in our stomach. So second one is sulfuric acid, H2SO4. H2SO4 is in present in chemistry laboratories. Then it comes the number of HNO3. HNO3 is nitric acid used for the preparation of fertilizers and explosives or pesticides. So next one is H2CO3 means carbonic acid. Carbonic acid is usually seen in fizzy drinks and soft drinks, etc. Like then comes citric acid. Citric acid we all are familiar with. It is always found in oranges and lemons. Then comes acetic acid. It is usually found in vinegar and also used in our foods and all for as a preservative. Let's come to bases. Bases are substances that produces hydroxide ions, which is OH minus ions, when mixed in water, basically. They are also known as alkalis. And properties of bases are they are bigger in taste, a bit bitter in taste. Sorry, it's the spelling is wrong here, but they are usually bitter in taste. Then their pH value is less than always greater than 7, means it lies between 7 to 14. Bases can conduct electricity. They are also good conductors of electricity. They are basically slippery in touch and also corrosive in nature, like acids. Let's come to some examples. Some examples of bases are as follows: NaOH twice, which is sodium hydroxide, also known as caustic soda, and used in washing soaps and all. Then comes KOH. KOH is potassium hydroxide, which is also known as potash and also used in soaps and shampoos. Calcium hydroxide, CaOH twice, which is also known as bleaching powder in our daily life and used to treat soil and water. Magnesium hydroxide, MgOH twice, used in acidic resistant medicines like antacids, which are always used to treat the uh, acidities and all. Then comes ammonium hydroxide, NH4OH. For production of fertilizers, this acid is basically used. Let's come to differences between acids and bases. Like we can see in this PPT, that acids are able to increase the H plus ion concentration in an aqueous solution. And aqueous solution means that the acids are mixed with water. Then and the difference between these both of these is, in acids we the increase of H plus ion concentration happens, and in bases increase of OH minus ion concentration happens. Then comes pH value. As we have already talked about it, the pH value for acids is less than 7 and for bases is greater than 7. Then comes litmus paper test basically. So acids turns blue litmus paper into red, and bases turns red litmus paper to blue. The color change indicate basically the litmus paper is an indicator, and it indicates that whether the solution is acids or bases. Then comes acid reacts with bases to form salts in an aqueous medium, and bases react with acids to form salts. Acid tastes sour and bases taste bitter. We have already talked about. Then comes types of acids. There are basically two types of acids: strong acids and weak acids. Strong acids are molecules that completely dissociate into their ions when it is in water. And weak acids are molecules that partially dissociates into ions in aqueous solution. pH of strong acids is very, very low. Means the value comes between 1 to 3 or 1 or 2. Then weak acids is pH of weak acids is between 3 to 5, or mainly it can go to 7 also. Then acid dissociation constant is a higher value, and acid dissociation constant is a lower value in weak acids. So release all the H plus ions to the solution, and weak acids do not release all H plus ions in the solution. Let's move to bases. Now, bases are also two types: strong bases and weak bases. A strong base is a compound that can completely dissociate into its cation and hydroxyl ions in aqueous solutions. And here comes weak bases. A weak base is a compound that partially dissociates. So, and strong bases dissociate into ions almost 100%. 100% OH minus ions are dissociated in water, this means. And partially dissociation into ions means OH minus ions are dissociated partially. Then comes indication of pH, which is always the strong bases have their pH value closer to 14, and weak bases have their pH value between 17 and 14. It can be anything. Then highly reactive and less reactive. Strong bases are very reactive. That's why they are corrosive in nature. So pKb value is almost zero, and pKb value is very high in weak bases. Let's move to applications of acids in our daily lives. Acids. Um, First of all, we will talk about acids, and then we'll move to bases. So some weak acids like acetic acids are used as food preservatives. As we have talked that acetic acid, the uses are in vinegar, and vinegar is used as food preservative. Then sulfuric acid is widely used in batteries, and nitric acid and sulfuric acid both are also used in production of fertilizers, paints, pesticides, etc. Phosphoric acid is present in soft drinks. We have talked about this earlier. So let's come to bases. Applications of bases are in our daily lives is basically sodium hydroxide, a very strong base, is used in production of soaps and papers. Then comes calcium hydroxide, is used in production of bleaching powder. Ammonium hydroxide, NH4OH, is used as essential reagent in chemistry laboratories. Means you will basically find NH4OH only in laboratories. So that's all for today. Thank you.